War, environmental destruction, global warming, species extinction. Spaceship Earth is being trashed by its crew. It's looking like humanity needs a plan B. Fast. And the obvious candidate? Well, it's staring down at us every night. Mars. It has a total surface area almost equal to Earth's entire land area, so there's room for all of us. And unbelievably large sums of money are being directed to space exploration. So it's not so out there to ask, what if we moved all 8 billion of us humans to Mars? When you measure it, Earth is 71% ocean. The livable area we live on is just a small part of the total. So even though Mars is a planet with roughly half the diameter of Earth, its livable surface area is strikingly similar to what we have on Earth. So Mars has room for us. Now, the most important element to sustain human life is water. Wherever we move to, we're going to need lots of water. And Mars may look like a dry rock, but unlike closer destinations like the Moon, it secretly has water, and plenty of it. Water on Mars exists as ice at the poles, or it's hidden in deep rock formations beneath the surface. The scientists have estimated that there's enough subsurface water on Mars to cover the entire planet 1 to 2 kilometers deep. Now, the next thing we'll need is air to breathe. And Mars has air. It's thin compared to Earth, but Mars has an atmosphere and weather systems to go along with it. Currently, the air can't sustain human life without a spacesuit, but it is something to build on. And given the choices of other close-by options, Mars is much better than the completely airless Moon, or our closest neighborhood planet, Venus, where the atmosphere is mostly carbon dioxide and sulfuric acid. It also has a surface temperature of a blistering 464 degrees Celsius. That's 867 degrees Fahrenheit. And an atmospheric pressure 93 times that of Earth. So, when you look at the hellscape that's Venus, Mars is pleasantly inviting. And then there's light. Wherever we go, we're going to need some sunlight. Mars is only 1.5 times the distance from the sun as Earth is, so it's only a little farther away. At that distance, Mars might seem like a cold environment compared to Earth, but it's close enough to the sun to receive a useful amount of sunlight that can be turned into solar power and to grow crops. And Mars has seasons, like on Earth. Mars's longer orbit means it takes longer to go around the sun, so a Martian year is longer at 687 Earth days. But it has a similar rotation to Earth. A day on Mars lasts 24.6 hours, compared to our 23.9. Plus, it has a very similar axial tilt of 25 degrees, compared to Earth's 23.4 degrees. And wherever we move to needs to be as close as possible. There are closer destinations than Mars, like Venus or Mercury, but by any measure, they're completely unlivable. So we're left with Mars as our closest habitable option. Now, the red planet is the only logical next step after the Moon, which itself is an unimaginably harsh environment. It's fit only as a launching pad to space. The Moon is a great stepping stone to other places, maybe a small colony, but certainly not for 8 billion of us. So Mars looks very promising. And colonizing Mars isn't just wild speculation. The race to Mars has already begun. We're about to see one of the most technically ambitious and well-resourced space programs in human history shift into high gear. The financial markets are already going there. Just look at the valuation of SpaceX in 2026, which came in around $1.7 trillion. And compare that with the operational budget of NASA's entire 13-year Apollo project in the 60s, that cost around $300 billion adjusted for inflation. That shows that this is by far the most well-funded space project in human history, by a multiple of 5. This is getting real fast. There's no question Earth is dying, and Mars has space. Mars has water. Mars has an atmosphere and sunlight. It's relatively nearby, and we've already got remote rovers exploring it. And one of the most valuable companies in the world is throwing all its capital and resources into getting there. All that's left is to get all 8 billion of us off Earth and onto Mars. So, how many humans have we put into space so far? 10,000? Maybe 1,000? Nope, 781. Not exactly an inspiring start. SpaceX is leading the charge right now, constantly wrapping up its launch schedule. But even with all that effort, the numbers are still tiny. SpaceX managed 96 launches in 2023, upping it to 134 launches in 2024, and hit an all-time high of 165 launches in 2025, which was their busiest year ever. But most of those launches have been without human passengers. Of the 781 people who have left Earth and touched space, SpaceX has only lifted 78 of them. Its Dragon spacecraft took 6 years and 20 different missions to get to that number, too. That's the entire track record of the most active rocket company on Earth, set against our target of 8 billion people. In the short human history of space travel, the single best year on record put about 70 people into space, which was a record set by a combination of NASA and other countries during the peak of the space shuttle program. And that was back in 1985. Now, the record for the most people in space at the same time was set much more recently, in 2023. And that record was tied again in 2024 when, drumroll please, 11 people were on the International Space Station, 3 on China's Tiangong Space Station, and 6 were aboard Virgin Galactic's VSS Unity spaceplane, which spent only part of its hour-long flight in suborbital space. So the record is 20 people, and it lasted less than an hour. Humans establishing a permanent presence in orbit is an incredible achievement, and more are on their way, but we're talking about evacuating Earth's entire population. So how difficult is this really going to be? SpaceX's most favorable projections for its Starship have a goal between 100 and 200 passengers per launch. For argument's sake, let's be incredibly generous. Elon loves to plan big and go even bigger, so let's give him the benefit of the doubt and multiply the high end of those numbers by 10. So every launch would have 2,000 passengers. Well, even at that accelerated rate, you'd need 4 million launches to move 8 billion people. Okay, let's frame this from the perspective of a human lifespan, not some abstract future, but as a project that someone born today has a chance of seeing reach completion. At 4 million launches, spread across a century of continuous, non-stop launching, that works out to about 110 launches of 2,000-person starships every single day for 100 years straight. Put that beside the actual record, SpaceX's busiest year ever was about 165 launches. Moving everyone within a century means sustaining roughly 240 times that annual rate. Not for one record-setting year, but for every single year, 100 years straight. And there's a huge complication to this scenario. You can't launch every day. Because Mars and Earth are moving in relation to one another, they only line up for an efficient journey every 26 months. So launches can't be spread out. They need to be crammed into the 46 or so windows of opportunity that occurred during that 100-year period. Okay, well, that would be 87,777 launches during those precious windows, and a standing fleet of ships ready to go, numbering in the tens of thousands. Now, if we were to dial back this hypothetical fantasy and use the number of ships that Elon Musk himself floated as an eventual goal of SpaceX, a fleet of 1,000 ships carrying 100 passengers each, launching during the windows of opportunity, well, the job would take 173,300 years. We're definitely gonna need a bigger lifeboat. Let's take our number and multiply it by 100, a measure of scale that's way beyond our current thinking, but also still inside the bubble of what's conceivably possible. Let's imagine that we can build ships that could carry 20,000 people per launch. A design that has no real engineering behind it. But to get a sense of this scale, think of the world's largest cruise ship, Royal Caribbean's Icon of the Seas. It's 365 meters long. That's 1,200 feet long, longer than 3 football fields. And it weighs 250,000 gross tons. Between the crew and the passengers, it holds about 10,000 people. So double that, stand it on end, and shoot it into space. Even at this gargantuan size, we would need 400,000 launches to get everyone off Earth. That's 11 launches a day for a century. And again, you can't launch every day. Even carrying 20,000 passengers each trip, the size of the fleet would still need to be enormous. A quick trip to Mars, given current technology, would take 200 days one way, 400 days round trip, with no time for turnaround. But the ship that went to Mars would have to wait there for a window of opportunity to return to Earth, so they wouldn't get back in time for the next launch window 26 months later. We'd have to maintain a fleet double the amount. That's 17,390 ships to keep to this launch schedule. And here's the kicker. Even if we start with a static base figure of 8 billion people, that figure is going to rise daily. To make it simple, let's say we stick with the wildly optimistic figure of 11 launches of 20,000 people a day. So that's 220,000 people a day leaving Earth. But there are approximately 360,000 births a day on Earth and about 160,000 deaths for a daily population gain of around 200,000. To get everyone off Earth and to safety, we'd have to launch a minimum of 10 ships with 20,000 people on them every day before we even started to evacuate any of the waiting 8 billion people alive today. And all this is without getting into the mind-numbing cost of lifting that much tonnage into space. The per kilogram cost of energy spent to send payloads into space is just the start. Humans need incredibly complex life support equipment, food, and waste management systems. So, unless we build a fleet of thousands of gigantic ships and focus all of humanity's resources on this project for over a century, we won't be moving to Mars. Elon Musk's aspiration is for a 1 million person city on Mars within 20 to 30 years. Even if we ran the numbers for a fraction of Earth's population, say 8 million, and we went back to the most optimistic numbers floated by Elon, we would be looking at between 40 and 80,000 launches. But the math we're dealing with is for 1,000 times that population. But let's say human engineering, labor, and resource allocation all rise to the occasion, and humanity pulls together and commits to this project for a century, and we move the human population of Earth to Mars. What happens next? How do we survive? Okay, the problem with Mars is that when you shine a critical light on it and look past the surface comparisons, it has none of the basics we humans need to survive. If you think Earth's resources are stretched thin, well, let's take a look at a planet that has virtually nothing to offer. The water on Mars is trapped in ice, the air is almost non-existent, there's no food source, the dust that covers the planet is toxic, radiation levels are sky high, and the sunlight is weak. When it gets down to the simple facts, Mars is going to try and kill you over and over and over again. All that subsurface water is buried so deep that it's almost impossible to get to. Drilling a hole 10 kilometers deep on Earth would be an engineering feat in and of itself. The air is too thin to breathe, so you need to wear a spacesuit at all times when outside. But even if you could go outside without a suit, the fine toxic dust that covers every inch of the planet will poison you. And even then, the planet doesn't have a global magnetic field blocking out radiation like Earth does, so the radiation bathing you is 100 times Earth's natural background level. Without protection, it will slowly and inevitably destroy your cells, so you need to be shielded more or less permanently. Plus, this barren planet would starve you. This would be the equivalent of having 8 billion people live in a submarine, permanently, never surfacing. Sound like fun? Well, there's more. Let's take a closer look at what kind of resources we'd need to survive on Mars. Well, there's a parallel right here on Earth, the harsh, unforgiving conditions in Antarctic research stations. Nearly everything for human survival there is shipped in from outside. 780 kilograms of food per person per year needs to be imported for the crew. The state-of-the-art experimental mobile greenhouse Eden ISS, built to grow food for crews on space stations, grew 268 kilos of food over about 286 days for a crew of 10, working out to about 27 kilos per person, roughly 3.4% of the 780 kilos a person actually eats every year. Almost all of these stations' operational energy needs to be imported too. Powered by diesel generators, the fuel is shipped in by boat and then flown in by plane. Locally generated wind power covers only about a fifth of the two stations' needs. The South Pole station runs on a lean few hundred kilowatts of power on average to support up to 150 people, but it still burns about 1.7 million liters of fuel a year. Scale up this Antarctic math for 8 billion people and stretch the supply line across 54.6 million kilometers, and the numbers start looking impossible. Nothing grows naturally on Mars. There's no viable soil, other than what Matt Damon might have left up there. And you can't just add water to the dust that's on the ground. It's dead. Every single calorie of food would have to be shipped in or grown in artificial greenhouses with imported soil. Feeding everyone on Mars at the Antarctic per person rate would require 6.24 trillion kilograms or 6.24 billion tons of food every year. An amount that, grown indoors at the best Eden ISS greenhouse yield ever achieved, would need a sealed, artificially lit farm about the size of the United Kingdom. The power for lighting and heat alone for 8 billion people on Mars, even at bare research station rates per person, comes out to roughly 9 times all the electricity humanity currently generates worldwide. Now, on a planet that receives less than half of Earth's sunlight, is prone to planet-wide dust storms, and has no natural fuel reserves. And building up an industrial base in the long term on Mars would have severe challenges. The simple fundamentals like no hydrocarbons for plastics and no coking coal for conventional steel would leave Mars lacking industrial basics. Due to a lack of critical resources, Mars would never be able to sustain some of the simple industrial chains that are essential to our modern technological world. Not to mention the very complex technological chains that drive Earth's current economy and tech industry. Semiconductor supply chains that only a handful of Earth's most advanced economies manage would be almost impossible on a planet like Mars. Mars would likely remain highly dependent on Earth for many of the survival level basics for centuries, maybe forever. And unlike colonies of the past on Earth, Mars wouldn't be a source of new wealth for the colonial home country, but an incredible resource drain. In the case of a dying Earth, the resources expended on the Mars project would only speed up our decline. The most radical fix would be to terraform the entire planet, transforming the dry, barren rock that is Mars into a fertile, green water world like Earth. But this process, even if it was possible, would take unimaginable resources and hundreds, if not thousands, of years to achieve. But let's say we did it. Humanity pulled together all its resources and achieved the unachievable. And we moved all 8 billion of us to Mars. And we solved the problems of water and radiation and dust and food and energy supply. Well, yeah, we still got a bigger problem. The problem is us. Because who's to say that the same 8 billion people who trashed Earth wouldn't do the same thing on Mars? Humans have reshaped Earth. We now live in the Anthropocene, a new geological epoch defined by human activity on Earth. We've changed the composition of the atmosphere. The atmospheric carbon dioxide is now 50% higher than it was before the Industrial Revolution. The ocean has absorbed enough carbon dioxide to increase its acidity by 30%. 44% of Earth's habitable land has been turned into agricultural land. And humans have wiped out 60% of the planet's mammals, birds, fish, and reptiles since 1970. In the past decades, these human impacts have accelerated at an unprecedented rate. Sometimes referred to as the Great Acceleration, we're increasing carbon dioxide emissions, ramping up global warming, speeding up ocean acidification, destroying habitats faster, killing off more species, and doubling down on natural resource extraction. This is our track record. This is what 8 billion humans are capable of. And there's no indication that we wouldn't just do the same thing again on a new planet. Same population, but in an even more fragile situation. It's hard to imagine how humanity will act living in an almost entirely artificial, closed-in world on Mars. But given the evidence, the citizens of Mars are likely to exploit, deplete, degrade their home in the same way they did on Earth. Now, add to this the fact that every colony a country's ever established has eventually turned away from its colonizer and fought for independence, many times violently. Just like when the American colonies turned against Britain, the interests of the Mars colony would eventually drift out of alignment with whatever political entity was left on Earth. But in this case, even a resource-depleted and environmentally degraded Earth would still look like a green paradise compared to the harsh, barren surface of Mars. Even a half-dead Earth, probably recovering after the exodus of humans, would be a strong temptation to a struggling Mars colony. Which leads us to the real deal. Any problem that's big enough to make us seriously consider fleeing the planet is far cheaper to fix here than to restart from nothing on Mars. That's a summary of Neil deGrasse Tyson's point of view on the matter. Neil, who is the director of the Hayden Planetarium, aka someone who really knows space. The harsh fact is that there is no plan B. But if we understand this profound truth, we might just have a chance. If we turned the resources we're currently committing to financial fantasies toward the real-world problems we face, well, we wouldn't have to leave Earth. Ironically, the global cooperation needed to plan and pull off mass immigration to Mars would be exactly the international coming together we'd need to move towards sustainability and to reverse Earth's decline. Fixing our problems here is far more realistic and achievable than escaping to space. But there is one external existential threat that we can't fix by ourselves here on Earth. It's happened before, and we probably won't be able to do anything about it. That's a direct hit by an asteroid that could render Earth completely uninhabitable. Even a small asteroid impact could scramble the global climate and send our complex and fragile civilization back to the Stone Age. We might be able to deflect or destroy an approaching asteroid threat if we had enough early warning, but there's also a chance we don't see it coming in time. This is not a fantasy situation. One of these asteroids has already ended an entire era of life. When the Chicxulub asteroid smashed into Earth, it changed the climate overnight, wiped out the dinosaurs, and redirected the trajectory of evolution. But that's a story for another What If.